Okay, so I want to factor the polynomial 2s cubed minus 27 minus 18s plus 3s squared, specifically by grouping. So in order to factor this by grouping, you first want to put this polynomial in the standard form. So if you notice the 2s cubed, s to the third power, that's the largest degree or power of s, so that's the first term. So it's 2s cubed. And then the next term would be the s squared term, so that's plus 3s squared. The term that comes after that is the negative 18s. And then lastly, the negative 27. So that's the polynomial in standard form. And then you want to group terms together. So I'm going to group these two terms together, the first two terms, and then these two terms together as well. Sorry, I forgot the S here. So if I look at just the first two terms, I want to look for a greatest common factor between the two terms. If you look at the coefficients 2 and 3, there's no greatest common factor other than 1. But then for the variable s to the third and s squared, the greatest common factor is s to the second power. So you're only factoring that out of the first two terms because you're grouping those together. And then what's left in each of the two terms, if you factor out an s squared, is in the first term, there would be 2s. And then just to double check that, s squared times 2s is 2s cubed. And then in the second term, if you factor out an s squared, what would be left is plus 3. Now I want to try to factor the second two terms by grouping. If you look at each of the two terms here, negative 18s and negative 27, since they're both negative, I'm going to factor out a negative. And then between 18 and 27, the greatest common factor is 9. And that's the greatest common factor between the two terms because the first term has an s in it, the second term does not. So you're factoring out a 9 just from the second two terms, not these two terms, because you're factoring by grouping. So if you factor out a negative 9 from negative 18s, you'd be left with 2s. And then again, to check, negative 9 times 2s is negative 18s. If you factor out a negative 9 from a negative 27, what's left is positive 3, because negative 9 times positive 3 is negative 27. So here's what you should notice. When you factored out the greatest common factor from the first two terms, what was left is 2s plus 3. And the exact same thing is left when you factor out a negative 9 from the second two terms. So then, since that's common in the first two terms and the second two terms, 2s plus 3. And then what would be left is the s squared minus 9. Could have actually written the polynomial s squared minus 9 first, and then times 2s plus 3. But here's the tricky part. The s squared minus 9, that's not completely factored. That's what's known as the difference of squares. So if you think about it like this, s squared, and then negative 9 is the last term. But if I'm putting the polynomial in standard form, s squared, that's the highest degree of s. What there technically is a 0s as the middle term. And you could either make the diamond or just try to factor this. If you make the diamond, coefficient of s squared is 1, and then the last term is negative 9, or 1 is a, and then c is negative 9. So I could put that on the top of my diamond. And then b is 0. So then you want to look for two factors of negative 9 that add to 0, and that would be positive 3 and negative 3. And then since a is 1, if you divide the 3 and negative 3 by 1, they're just going to stay the same. So s squared minus 9 or s squared plus 0s minus 9 would actually factor into s plus 3 times s minus 3. So even if you factor by grouping on the entire polynomial, you're not done. You could still factor s squared minus 9. So then what we would be left with is 2s plus 3 and then the s squared minus 9 factors into s plus 3 times s minus 3. I'm running out of room here. And then I noticed that should be 3 instead of 9. And that's what it would factor into.